Electrical codes and regulations are paramount to ensuring the safety and efficiency of electrical installations. Without direct access to specific code references, understanding general principles and best practices becomes even more crucial. Firstly, always prioritize safety when working with electricity. Electricity can be dangerous, and improper handling can lead to severe injuries, fires, or even death. Before starting any electrical work, ensure that the power is turned off at the main breaker or disconnect switch. Use appropriate personal protective equipment, including insulated gloves, safety glasses, and non-conductive footwear. Secondly, familiarize yourself with the National Electrical Code, or NEC. While I cannot access external websites of specific NEC sections, the NEC serves as a comprehensive standard for electrical installations. It provides guidelines on wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years, so it's essential to use the latest edition. Thirdly, understand the fundamentals of electrical circuits. An electrical circuit consists of a source of power, a conductor, a load, and a return path. The source provides the electrical energy, the conductor carries the current to the load uses the electrical energy to perform work, and the return path completes the circuit. Fourthly, learn about different wiring methods. Common wiring methods include non-metallic sheath cable, or NM cable, also known as Romex, electrical metallic tubing, or rigid metal conduit, or RMC, and flexible metal conduit, or FMC. Each wiring method has its advantages and disadvantages, and the appropriate choice depends on the application and the environment. Fifthly, understand the importance of overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current flow. Overcurrent can be caused by short circuits, overloads, or ground faults. Circuit breakers and fuses interrupt the circuit when the current exceeds a predetermined level, preventing damage to equipment and reducing the risk of fire. Sixthly, learn about grounding and bonding. Grounding provides a lower impedance path for fault current to return to the source, tripping the overcurrent protection device and clearing the fault. Bonding connects all metal parts of an electrical system together to equalize the voltage potential, reducing the risk of electric shock. Seventhly, understand the different types of electrical equipment. Electrical equipment includes panel boards, switchboards, transformers, motors, lighting fixtures, and appliances. Each type of equipment has specific installation requirements that must be followed to ensure safe and reliable operation. Eighthly, be aware of the different voltage levels. Common voltage levels in residential and commercial buildings include 120 volts, 208 volts, 240 volts, 277 volts, and 480 volts. Each voltage level has specific applications and safety consideration. 120 volts is commonly used for lighting and small appliances. 208 volts is often used for three-phase power in commercial buildings. 240 volts is used for larger appliances, such as ovens and air conditioners. 277 volts is commonly used for lighting in commercial buildings. 480 volts is used for large motors and industrial equipment. Ninthly, follow manufacturer's instructions. Always follow the manufacturer's instructions when installing electrical equipment. The instructions provide detailed information on proper installation procedures, wiring diagrams, and safety precautions. Tenthly, obtain the necessary permits and inspections. In most jurisdictions, electrical work requires permits and inspections. Permits ensure that the work is performed by qualified individuals and that it complies with the electrical code. Inspections verify that the work has been installed correctly and safely. 11thly, use appropriate tools and equipment. Use only tools and equipment that are designed for electrical work. Ensure that your tools are in good condition and properly insulated. Use a voltage tester to verify that circuits are de-energized before working on them. 12thly, understand the concept of ampacity. Ampacity is the current carrying capacity of a conductor. The ampacity of a conductor depends on its size, material, and insulation type, as well as the ambient temperature and the number of conductors in a raceway or cable. The NEC provides tables that list the ampacity of different conductors under various conditions. 13thly, learn about voltage drop. Voltage drop is the decrease in voltage along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop and recommends limiting voltage drop to a certain percentage of the source voltage. 14thly, understand the requirements for ground fault circuit interrupters, or GFCIs. GFCIs are devices that protect against electric shock by detecting ground faults. GFCIs are required in areas where there is a high risk of exposure to moisture, such as bathrooms, kitchens, and outdoor locations. 15thly, learn about arc fault circuit interrupters, or SIs. SIs are devices that protect against fires caused by arcing faults. Arcing faults are dangerous electrical faults that can occur when electricity jumps between conductors or to ground. SIs are required in many areas of the home, such as bedrooms and living rooms. 16thly, understand the requirements for surge protection. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning or other events. SPD are recommended for sensitive electronic equipment such as computers and televisions. 17thly, be aware of the requirements for emergency lighting. Emergency lighting is required in many commercial buildings to provide illumination during power outages. Emergency lighting systems must be designed to operate automatically when the normal power supply fails. 18thly, learn about the requirements for fire alarm systems. Fire alarm systems are designed to detect fires and alert occupants of a building. Fire alarm systems must be installed and maintained in accordance with fire code. 19thly, understand the requirements for hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. Electrical equipment installed in hazardous locations must be specially designed to prevent ignition of the flammable substances. 20thly, be aware of the requirements for swimming pools and spas. Swimming pools and spas have specific electrical requirements to protect against electric shock. These requirements include bonding of all metal parts, use of GFCIs, and proper grounding. 21stly, understand the requirements for renewable energy systems. Renewable energy systems, such as solar photovoltaic systems and wind turbines, have specific electrical requirements to ensure safe and reliable operation. These requirements include proper grounding, overcurrent protection, and disconnect switches. 22ndly, learn about the different types of electrical drawings. Electrical drawings are used to communicate the design and installation of electrical systems. Common types of electrical drawings include single-line diagrams, riser diagrams, and wiring diagrams. 23rdly, understand the importance of labeling. Labeling is essential for identifying electrical equipment and circuits. Labels should be clear, concise, and durable. 24thly, be aware of the potential hazards of working with energized equipment. Working on energized equipment can be extremely dangerous. If it is necessary to work on energized equipment, follow strict safety procedures such as using insulated tools and wearing appropriate personal protective equipment. 25thly, learn about the lockout/tagout procedures. Lockout/tagout procedures are used to prevent accidental energization of equipment during maintenance or repair. Lockout involves physically disconnecting the equipment from the power source and attaching a lock to the disconnect switch. Tagout involves attaching a tag to the disconnect switch to warn others not to energize the equipment. 26thly, understand the importance of electrical safety training. The electrical safety training is essential for anyone who works with electricity. Training should cover topics such as electrical hazards, safe work practices, and emergency procedures. 27thly, be aware of the latest developments in electrical technology. Electrical technology is constantly evolving. Stay up to date on the latest developments by reading industry publications, attending conferences, and taking continuing education courses. By following these general principles and best practices, you can ensure that your electrical work is performed safely and in compliance with the electrical code, even without direct access to specific code references. Always prioritize safety, use appropriate tools and equipment, and obtain the necessary permits and inspections. Remember to consult with a qualified electrical contractor if you have any questions or concerns. Electrical work should only be performed by qualified individuals who have the necessary knowledge, skills, and experience. If you are not qualified to perform electrical work, do not attempt to do so. Contact a licensed electrical contractor to perform the work for you. They will ensure the safety and correctness of the electrical installations.